Hello, this is lesson 2.1. Today we are going to be talking about multiplying integers. So let's take a look at our standards and our objectives for today. So this is our second unit in math from this year, multiplying integers. And our objective today is I can multiply integers using a number line and using multiplying rules with integers. You're going to find that the multiplication rules are different from the adding and subtracting rules that we've been learning in Unit 1. Our standards are NS2 and then NS2A, which is your subcategory from NS2. Apply and extend previous understandings of multiplication and division and of fractions to multiply and divide rational numbers. And 2A, understand that multiplication is extended from fractions to rational numbers by requiring that operations continue to satisfy the properties of operations, particularly the distributive property, which is something you would have learned in 6th grade. Leading to products such as -1 times -1 is equal to 1, and the rules for multiplying signed numbers. Interpret products of rational numbers by describing real-world context. So I'm going to minimize myself, and we will get started here. So here's Yoda. Multiplying integers you must. Fail me no. Okay, hopefully that makes sense to you. Move on a little bit here. So a little bit of review. What is an integer? We talked about it in our first unit. Remember what an integer is? Exactly, it's a positive whole number or a negative whole number. It's the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -1, -2, -3, -4, -5. It's not the in-between numbers, right? They're the numbers on the number line, but not the in-between numbers. So remember this little chart here, integers there, -2, 2, they're integers. 3.5 would not be an integer, or 3.25, or 3.7643 would not be an integer. Okay, using a number line to multiply integers. So here's a word problem. Montrell forgot his money for lunch, so he had to borrow $2 each from 3 different friends at school. How much does he now owe in debts? So we have our number line here. So he borrowed $2, so that's a -2. From the second friend, he borrowed another -$2, so we add those together. And finally, from the third friend, he borrowed another $2, which makes another -2. From the last unit, you should know what -2 plus -2 plus -2 equals. Right, a -6. So you can use repeated addition, just like that. -2 plus -2 plus -2, right? And we decided that was -6. But this unit is all about multiplying and dividing integers. So is there a way we can rewrite this problem using multiplication? What do you think? Did you come up with 3 times -2? Why would you say 3? Because there are 3 of these -2s here. 1, 2, or he borrowed from 3 friends, right? 3 times the amount he borrowed, -2, will give you -6 as an answer. There is your answer. Okay, let's do another one. Layla plays a video game in which she loses points. She loses 3 points at 4 different times during the game. What is her score? There's our number line. She loses 3 points the first time, plus she loses 3 points the second time, plus she loses 3 points the third time, plus she loses 3 points the fourth time. So this is repeated addition. -3 plus -3 plus -3 plus -3. That should give you what? Using repeated addition? Yes, negative 12, right? And there it is, negative 12. How can you rewrite this equation using multiplication? What do you think? Okay, 4 times negative 3, because you have negative 3 4 different times, and you'll get the same answer, negative 12. See that? Okay, wanted you to see how this works. Okay, you get to give this a try for a moment. I'll see you back in a second. Okay, welcome back. Let's continue our lesson. There are certain rules for multiplying integers. Here are the rules. A positive times a positive is going to equal a positive. A negative times a negative is also going to equal a positive. A positive times a negative is equaling a negative, as well as a negative times a positive equaling a negative. 0 times a positive or a negative is always going to be 0. So for example, if I did 2 times 3, they're both positive numbers, I will get a positive answer of 6. If I have two negatives, negative 2 times negative 3, I will get a positive answer of 6. It's different than adding and subtracting. If I have one negative or one positive, I have one positive times one negative, I get a negative answer, negative 6. If I have one negative times one positive, I also get a negative answer, negative 6. And then the last one, if I have negative 3 times 0, I end up with an answer of just 0. Or if I have a positive number times 0, I still get 0 as my answer. So those are number examples of that chart. You're going to want to memorize this. You're going to be using these rules for a very long time to come in your math career. Let me just clear this because there's a way to simplify this. The way to simplify this is to say that numbers that have the same sign, both positive or both negative, are going to have a positive answer. And numbers that have different signs are going to have a negative answer. That's much different than addition, right? Because addition will take on the sign of the bigger absolute value number. And it will not necessarily do that with multiplying and or dividing. Okay, I have a song for you, it looks like. So let me press play and get my volume up there a little bit here. Let's take, which one is my speaker? Hold on just a sec here. Okay, I'm ready. Here's the song. You're gonna love it.
I saw you working with the two integers. The math you did was right, now that's for sure. You were going strong, but the final sign was wrong, 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 wrong. So listen to this song and you'll be right every time. Follow these two rules when you multiply or divide. Same signs positive, different signs negative. Yeah, same signs positive, different signs negative. Now let's practice a problem or two. Negative 5 times 4, what do we do? We look at the signs, then we multiply. Since they are different, it will be negative. But what if I had negative 12 divided by negative 6? See it, same signs positive, Different signs, negative, yeah, same signs, positive. Different signs, negative, same signs, positive. Different signs, negative, yeah, same signs, positive. Different signs, negative.
Now let's practice a couple. Tell me whether the solution is positive or negative. 3 times negative 8. Negative 4 times negative 9. Negative 36 divided by negative 3. 54 divided by negative 6.
Okay, hopefully you enjoyed that. If I can get out of that. And we will continue with our math lesson. Okay, so those are the rules for multiplying, and we'll just look at them again. 2 positives equal a positive, 2 negatives equal a negative. Positive times a negative equals a negative, and a negative times a positive equals a negative, and anything times 0 is just 0. Same signs equals positive, different signs equals negative, okay? So multiply these integers. We're going to try this. Negative 3 times positive 5. By the way, that means multiplying when you see a number here times another number in parentheses. So that means to multiply. You're going to, as you get in higher math, you're going to stop seeing the multiplication sign between numbers. Another way people show it when you get into higher math is to put a dot in between there. A dot is also a way of showing multiplication. Okay, so let's see, what's 3 times 5? Negative, did you get it? Negative 15. Different signs, right? One is negative, one is positive, so the answer is going to be negative. 7 times negative 6. One is a positive, one is a negative. Look at your chart. Different signs. You're going to have an answer of negative 42, correct. What about this one? Negative 15 times negative 3. Is the answer going to be positive or is it going to be negative? Exactly, they're both negative signs. So the answer is going to be positive. Same signs equals positive. Did you guess positive 45? Then you are correct. What about negative 10 times negative 2? Did you say 20? Excellent work. 0 times negative 22. Any number times 0 is just, you guessed it, 0. 8 times 4. 2 positives equal a positive. So 8 times 4 is 32. So positive 32. 13 times negative 3. 13 times negative 3. Negative or positive? Exactly, negative. Negative 39. And by the way, if you don't know how to multiply 13 times 3, I do everything vertically so I don't get messed up. Go like this. 3 times 3 is 9. 3 times 1 is 3. And then it takes a negative sign because you have different signed numbers. And then the last one on this page, negative 5 times negative 8. Positive 40. Correct. Okay. Now it's your turn to give these rules a try. Okay, welcome back. Let's continue our lesson. We're going to talk about focusing on higher order thinking. The rules for multiplying 2 integers also apply when multiplying 3 or more integers. Always multiply 2 numbers at a time. Apply the rule. and multiply your answer with the third integer and then the fourth integer and so on and so on. So how would that work? What if we were to multiply 3 times 3 times negative 3? Well, first we multiply two integers, so we'll do 3 times 3. They're both positive, so we'll get a positive 9, and then we're going to multiply that positive 9 times a negative 3. So now we have a positive times a negative. Different signs, our answer is going to be negative. What's 9 times 3? 27, so negative 27. Okay, that's how it works with 3 numbers. Let's see if that brings out a number answer out here. Oh, we didn't bring our answer out. We're going to try all of these. Okay, so we decided that was negative 27. Let's see about the one right below it. 27. So here we have 3 times negative 3. What's that going to be? Two different signs. We're going to end up with negative 9. Negative 9 then times the negative 3 is going to be 2 negatives, which will end up being a positive 27. Okay, on the right you have 4 numbers. Let's do that. Well, what's 3 times 3? They're both positive. Positive 9. Then we're going to multiply that 9 times the 3. They're both positive. That's going to give us 27. And then we're going to multiply that 27 times negative 3. So now we have a positive and a negative. We're going to end up with a negative answer. So if you don't know what 27 times 3 is, do this vertically. That's what I'm going to do. So 3 times 7 here is 21. Put down the 1 and carry the 2. 2 times 3 is 6, plus 2 is 8. And remember, we decided it was going to get the negative sign because we had a positive and a negative. So negative 81. And the one on the bottom here, 3 times 3 is positive 9. And we're going to multiply that by negative 3. That will give us negative 27 because we have a positive and a negative. And we're going to multiply negative 27 times negative 3. 2 negatives will give a positive 81. Okay, so when you have multiple numbers that you're multiplying together that are integers, take them 2 at a time, apply the rule, and then continue multiplying with the next number in the row. Okay, let's wonder if it's going to bring up the number answers here. Nope. Okay. Okay. When a product of integers has an odd number of negative factors, then the sign of the product or the answer is what? So if we have what we had before, we had 3. When the product of integers has an odd number of negative factors, so let's say 1 negative times 2 positives, we're going to end up with the sign of the product. What was the sign going to end up being? Right, the sign is going to be negative. So that's an odd number. 3 is an odd number. If I had 4, right, what would happen with that? Let's say I just had 1 negative. What's going to happen? It's going to be positive or is it going to be negative? Well, this will give us negative. Negative times positive will give us negative. Negative times positive, that's also going to give us negative if you have 1 negative. If you have 2 negatives, right, that's an even number of negatives. You're going to end up with a positive answer. So it just depends. To kind of think through that a little bit. I'm going to clear. And we'll bring up the answer here. Positive or negative, we just decided it would be negative, right? We had an odd number of negative factors, yes. When a product of integers has an even number of negative factors, then the sign of the product or the answer is, yes, positive should be what you say. Okay, good. Okay, let's take a look at a little bit more. The product of 3 integers is negative 3. Determine all of the possible values for the three factors. The product or the answer is -3. What could we multiply together? We need 3 factors. What can we multiply together to give us -3? Well, 1 times 3 times, don't say 3 because that'd be 9, right? Times another 1. But that's going to give us a +3. So if I just make one of them negative, will that work? -1 times 3 is -3. And a -3 times a +1 is going to give me a -3. So yes, that would work. That's one possibility. What about 1 times -3 times 1? Will that work? Will that give us a -3? Exactly, it will, right? Okay. What about 1 times 3 times -1? Will that give us a -3? Of course it will. Okay, so let's clear this and pull down the answers. So there's our -1 first. There's our -3 second. And there's 2 negative. Oh, look at that one. I didn't think of that one. -1 times -3 is a +3. Let's do that one. It's a +3 here. And then positive, oh, not that one. Clear. Undo. Bottom one. -1 times -3 is +3 times -1. It's going to give us a -3. Okay? So you got to be thinking through that a little bit. That's why it's called higher order thinking. Okay, give it a try with 3 numbers like this. Okay, welcome back. We are ready to do our homework for lesson 2.1. It'll be on your Google Classroom. And I hope that you have a great day and we will see you soon. Bye.